Hi class, so in this video I'm going to show you the solutions of the activity in your MOOC, which is activity 4.4, where you have first law of your open system. So this is actually the device of your turbine. So let's read what you have here. You have steam flows steadily through an adiabatic turbine. The inlet conditions of the stream are 10 megapascal, 450 degrees C, and 80 meter per second. And given your exit condition as 10 kilopascal and you have 92% quality at the velocity of 50 meter per second. The mass flow rate given of the steam is 12 kilogram. So you need to find the change in kinetic energy, which is your KE. The power output, which is W dot, and the turbine inlet area, which is your A1. So let's have a look at your friend's solutions in here, right? So because this is a turbine, so I prefer that you sketch your turbine. Indicates your in and your out and also your work. So turbine produces work, so you are going to have W dot out. And this is your inlet, which is denoted as 1, and your outlet denoted as 2. And if you see here, your friends already do this, which is state 1, 10 megapascal, 450 and 80 meter per second, and your state 2, 10 kilopascal with quality of X 0.92. Now, what does it mean by quality of X? So when recall back that when you solve for your thermodynamics problem, you need to identify what type of working fluids you are working on. So in this example, this is actually your steam turbine. So this is vapor. So when you have a vapor, straight away you need to plot this TV diagram that will shows you the conditions of your states, right? So when you plot your TV diagram together with this bell curve, right? Now you can specify your condition, which is you have two pressure, one as 10 kilopascal and another one is 10 megapascal. And then what happened is that given your state 1 is 10 mega and then state 2 is 10 kilopascal. So you know now that this pressure line is higher than this pressure line. And we already discussed that turbine, the effect of the turbine is a pressure drop. So that's why this sketch should be vertically down. Okay. And note that this state 1, given to you state 1 is your temperature. So recall back in your previous class, as I said, when you have a pressure and temperature given, it is actually already in your superheated region out of this bell curve, right? And then it says that the steam go through your turbine and it stops at the state 2 where you have 10 kilopascal and the quality is 92%. So quality here is actually your fraction of vapor or your quality X, which is 0.92, indicates that there are already change into your vapor and only certain liquid left. Okay. And recall back that as I told you, when you are given your pressure or temperature and the value of your X, your specific volume V, or your internal energy U, or your enthalpy H, you can always refer to your table E5 in order for you to solve the unknown value. So state 2 actually you need to refer from table E5, and this one, given your pressure and temperature, you can refer from table A6, which is superheated region. Table A5 is actually indicates that this one is in mixture region. So next is how are you going to solve this, right? Knowing that we are trying to solve for your first law open system, so we start with your energy balance, right? And then you expand it into this form. Okay, so since it doesn't mention anything about your potential energy, and assume the datum is the same, so you can cancel out your potential over here. And also it says here that the turbine is an adiabatic turbine, which means there's no heat gain and also there's no heat out or heat loss in the system. And because this is your turbine, so it actually produces work. It doesn't use your work, so you can cancel out this work term. Left with you the enthalpy, which is the energy of your working fluid, and also your velocity over here. Now, since the working fluid is your steam, so it's already given that your state 2 pressure and temperature, your state 1 pressure and temperature, and your state 2 pressure with this X value here. So now you can make use of your property table in order to obtain your value of H2 and H1. C2 and C1 is already given to you in the questions, right? The flow of steam inside your turbine, the velocity. So how are you going to find your H1? So based on table A6, so this is the value of property table for your steam at superheated, right? You refer to table A6. So we have 10 megapascal and the temperature was at 450 degrees. So as you can see here at 10 megapascal, 450 degrees C, this is the value of your H. So your friends got 3.3242.4 kilojoule per kilogram, right? And then what about your state 2? So state 2, you can read from your table A5 because given to you pressure. If it's given to you temperature, so you need to read from table A4. So it is at 10 kilopascal, where you will need your H, your HF, as well as your HFG, so that you can plug into this equation, which is generally y is equal to yf plus x yfg. So this is exactly what your friends did here, right? So once you get the value of your H1 and your H2, and it's already given to you your C, so you can plug into the value over here. Please note that the unit for your enthalpy is in kilojoule per kg, and for velocity here, when you square, it's becoming meter squared per s squared. So you need to change into this kilojoule per kg, so it become a uniform unit. So in order to change your meter squared per s squared, it is equivalent to 1 kilojoule per kg is equivalent to 1000 meters squared per s squared, right? So you plug in the value of your C2, 50 meter per second squared, minus your 80 meter per second squared divided by 2 or 2000, since you want to change it into kilojoule per kg. So this is the value that you got, and in the end it will give you these answers, which is 10.2 megawatt. It is about the same, this one, right? And it's also answering the first question over here, which is negative 1.95 kilojoule per kg, right? You need to change into this equivalent unit first. Alright, so next question is for you to find the inlet area. So this is the mass flow rate where you have a velocity c, your area at 1, and the specific volume. You will need your specific volume here, right, in order for you to get this A. But the question is, how are you going to get the specific volume? Remember that in your property table, one of the property given is your specific volume, where the relations you have your kilogram and your meter cube. So since we are dealing with state 1 is actually your superheated, so you have 10 megapascal. You have 10 megapascal at 450 degrees C. So the reading of your specific volume is 0.029782. So this is how your friends get the value of 0.029782. The unit must be meter cube per kilogram. Okay. So now it's all about cancelling the unit in order for you to obtain this meter squared. So you plug in into these equations, and finally you will get the inlet area to be 0.00447 meter squared. Or you can change this into centimeter squared. Alright, so I hope this video made from your friends solutions is going to help you in understanding this problem solving on open system, where you have a turbine and the working fluid is your steam. Not to forget to sketch the diagram of your turbine over here, so you will always bear in mind that the turbine is going to make your pressure drop at the outlet. Alright, I hope this video will help you in your learning process. Thank you.